In today's episode, we're going to be covering file handling. Let's start. Here's our file from the last episode, and we did a lot yesterday. But I'm going to create a new file because we're not really adding on this episode. I want to create a new program, so here we go. I'll call it file_handler.asm. Here we go. Alright, there we go. I have a very simple return 0 project right here. But what I want to do is I want to take user input, but not in the way we have before. You see, what we do is we take user input after we run it. What I want to do is use an argument from the command line. Basically, when you run it, you add a second or third word, and that gets taken in, like argv in C. Every assembly program does actually use the stack, even if you don't specify to use it. There are more registers than just these general purpose registers, and the main one I'll be talking about right now is the stack pointer. As the name suggests, the stack pointer points to the part of the stack that you can now push or pop from. One thing to know about assembly is that pretty much every instruction can be made manually. For example, if you do push EAX, you are essentially saying subtract ESP, which is the 32-bit stack pointer, subtract ESP4. This gives you 4 bytes to work with, which is the size of the stack if you're using 32-bit. And now next we do move into the address of ESP plus 4 EAX. This and this are the exact same, but other than just pushing and popping, what else can the stack pointer be used for? Well, the stack pointer also holds the different arguments you put into running the program. Now let's compare the D word, which is a size, so that the program knows how much you're checking, and then the address of ESP, and now the number 2. Now because we only want 2 arguments specifically, we'll do jump not equals exit, and now we'll create a new exit label. That's just what we programmed before, which returns 0. Now if we input 2 arguments, this will be skipped, so let's jump read file. Now we can create a new label called read file. Now let's start by opening the file, so let's do move EAX5. This is the syscall operation for sysopen. Now in EBX we have to store the address of the file name, not actually the file name itself. So just use a regular move instruction, EBX, and now, here we go, we do the address of ESP plus 4, so this is the first argument, which is actually the program being called itself. So if the executable you're running is called main, then main will be the first argument. So this says main, and now we add 4 times 1. 1 in this case is the index of the argument we want to have. Now we do our interrupt, same as always, so 0x80. Now I do want to mention that syscall is actually the same as interrupt 0x80. I don't really know if there is a difference, I'll mention that in the next episode, or I might just Google it just now. But they mean the same thing. If you see this in another program, it practically means the same thing, and I'm pretty sure it's the exact same. But I decided to Google it. Syscall is actually a 64-bit operation, while interrupt 0x80 is a 32-bit operation. And syscall is actually not supported on 32-bit mode in Intel processors. Why this is, I don't know, but if you want to have backwards compatible code, use int 0x80, and if you want to use a more modern version, I don't really know what the difference is still, use syscall. Next, let's compare EAX with 0. EAX actually stores the file descriptor after this operation, and if it's less or equal to 0, then it went wrong. So let's do jump if below or equal to exit. Now if it did go correct, let's move into EBX EAX. This is for no real reason other than in a later operation, EBX is used as the file descriptor, so it's just simple to do it this way. Next, let's make a new section because we need a buffer to put all of the text in that is in the file. So we'll make buffer in a .bss section, is res b. Let's just do 1024 bytes. Oh yeah, and let's also store the length. So length equals 1024, just like our buffer. Now down here, let's move into EAX, the number 3, which is the operation for reading from a file. Now let's move into ECX, the buffer, and into EDX, we move the length. Not a lot to say about that, since it's very similar to other instructions we've seen before. Next, let's do a print statement, but before that, I want to move into EDX, EAX, because EAX actually stores the amount of bytes that was in the file that we read. Now let's just make a standard print statement, just like always. So move EBX0, move ECX, buffer, and now we can do interrupt 0x80. Now there is a bit of an issue because EBX is being overwritten here while we need to use it to close the file later. So let's just write another push statement. So let's do push EBX, and down here let's do pop EBX. Now we can just go ahead and close the file, so let's move EAX6, and now we can just immediately interrupt because EBX already is stored. Now to avoid a seg fault, we can just jump exit, and now we're done. Now before I assemble and link this, I want to issue a correction on episode 4. I briefly mentioned this in the last episode, but calling a function actually pushes something onto the stack, which I didn't know in episode 4. So what I did here is technically correct, but only if I used a jump instruction right here. And while we're here, I'd also like to mention that I never returned here. This doesn't matter, because it always exits before it tries to return. However, if you want to do this correctly without doing this, we can just do return, and now we don't have to have those two unnecessary lines, and everything under this call will actually get executed. With that out of the way, let's create a file for our program. Let's do test.txt, and in here we'll just put 5. Now if we assemble and link the correct file and do test.txt, we should get 5. There we go. Now if I type hello world and run this, there we go. Thank you for watching. Hi. On a slightly more serious note, I do want to mention that I'm probably not going to keep uploading these every day. I have quite a lot of trouble recording videos because not only is this kind of my first ever video series, it's also my first time putting effort into the videos I upload, so there's quite a lot of learning to be done. I don't really talk about it too often, but I do actually have Tourette's. It's quite difficult to record a video when every 5 fucking seconds, oh my god. If you notice a lot of cuts in my videos, it's because I excessively edit out the ticks that I get. It's really hard to record a video when you kind of involuntarily move your head every 5 seconds. For example, I've been recording for over 5 minutes. Not only that, but also this entire video, and the last video, took over an hour to record. I'm very proud that I've been able to create a series that I'm actually continuing, but if you notice it slowing down, that's why. Thank you for watching.